What part of this circle gets dilated? Okay, the radius. It's not 9 itself, it's what? What is the radius? 3. And what do we do to 3? Double it to 3, doubled is 6. Now, when you put it back in the equation, it will no longer be 9. It will no longer be 6, but what? 36, all right? The center does not get changed because we're dilating it about its own center. What is the center? What's the center? 6, 0, because nothing's being subtracted from right. Remember, we take these out opposite. With that said, we're going to go to problem 25, right? So problem 25 gave you I think the equation solving, if anything, might have been all right, one was like this. The other one was like this. All right. So they told you that this is 2x minus 4. They told you this is 39. My turn to talk, Brian. They told you this is x plus 6, and they told you this was 24. So in the directions they told you similar. So if I do left over right, the left at top is 2x minus 4. And the other left is 39. Now, what corresponds to 2x minus 4 in the other one? And what corresponds to the 39? All right. So 25 and 26 were heavy on the algebra. And I am counting on the fact that you remember how to do this. And so were they. All right, so then we're going to say 24 times 39, and I have no idea what that is. So when we go to multiply, we're going to distribute the 2x and get 2x squared plus 12x. Then we're going to distribute the negative 4 and get negative 4x minus 24 equals 936. Why don't you keep that? So now we're going to have 12x squared plus 8x minus 24, all right, equals 936. When you have a quadratic, which this is to the second power, this is to the first power, we have to have this side to be 0. So you've got 2x squared plus 8x, and 936 minus 24, I believe, is 912. 6 take away 4, 3 take away 2. All right, now, are they all, yes, sir? Okay, so now I add them because I'm subtracting 936. Good eye. So it's 36, 46, 56. I think it's 960. All right. So now, are they all even? Is everybody even? So I'm going to divide everybody by 2. So this is going to be x squared plus 4x minus 480, I believe, equals 0. So you can either factor this or use quadratic formula. Anybody remember quadratic formula? Okay, a squared plus b, it's ax squared plus bx equals 0. Yeah. This is a, this is b, this is c. In other words, a is 1, b is 4, c is negative 480. But then what do? We don't need the x's. Here's the x. X equals, what is it? Opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. The expectation is that you know this from Algebra 1. Okay, so when you have a square and an x to the first, you always have to do this. Opposite of 4 plus or minus, what's 4 squared? 16 minus 4 times a times negative 480 all over 2 times 1. So this is going to be negative 4 plus or minus the square root of 16. Negative times negative is positive 0.32, 1920. All over 2. So we're going to have negative 4 plus or minus, would you do the square root of 1936? What do we get? So this is going to be negative 4 plus or minus 44 all over 2. Now, how do we do this? What does that mean? That means negative 4 plus 44 over 2, or negative 4 minus 44 over 2. This gives me 40 over 2, which is 20, or negative, I'm going to say 88, negative, positive, negative, subtract 40. Yeah, so now this is negative 48 over 2, which is negative 24. Can you have a side length negative? So it's only going to be the 20. Yes. And the quadratic formula was needed on number 26 also. So you need to know that quadratic formula. Other questions? Yes. 26. So on 26, if you set it up, you would have said small side 10 is to small side x plus 2. So let's look at this, because this is going to be a huge part of what we do tomorrow. 26. So they told us that this was x plus 2. This is x plus 14. This is 10, and this is x. How long is this? Good. 10 plus x. So I'm going to put x plus 10 because that corresponds to 10, and x plus 14 corresponds to 2. 10 is to this whole side, 10 plus x, as x plus 2 is to that whole side, x plus 14. I did small to large.
So when it x plus 2 is like x plus 2 plus x plus 2, yeah.
So when you cross multiply, you have 10 times x plus 14 is equal to x plus 10 times x plus 2. Distribute. You're good at distributing. That is well in place, all right? So if you don't remember how to do this, it's just double distributing. And you're good at distributing, so you should be good at this. So we got x squared plus 2x. Now we're going to distribute the second one. So that's going to be 10x plus 20. So if you notice, again, we have x squared plus 12x plus 20. There's an x squared. So that means everything has to go to the other side. Minus 140. So this is going to be 0 equals x squared plus 2x minus 120. So what is A? 1. What is B? And what is C? Negative 120. So x is going to equal the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. So that's negative 2 plus or minus the square root of 4 plus 480 all over 2, which is negative 2 plus or minus the square root of 484. What is the square root of 484? No, it can't be. No, 484. It's got to be pretty. 22? It had to be pretty because I factored it last period. So we got negative 2 plus 22 over 2. You've got negative 2 minus 22 over 2. This gives me 20 over 2, which is 10. This is negative 24 over 2, which is negative 12. Which one works?
Wait, why can't you just switch those positive knowing negative?
Well, I just want to make sure in Algebra 2 you'll have to find both. So again, this is a preparation for your Algebra 2. Any other questions? Those were the two hardest, yes, ma'am. Okay, 17 did not give you a picture. You needed to draw that picture. So we have a Washington Monument. There's the Washington Monument. And we have a 1.8 meter tall person. And it casts a shadow, which means we must have a sun somewhere up in the sky. There it is. It is yellow. Yes, it's called indirect measurement. And because the sun is going to cast shadows that are proportional.
Does it matter how far you're away from the thing?
No. So this is the man's shadow. This is the monument shadow. You with me? This is the little bear thing. These are right angles. They both share this angle. So by angle, there's similarity. This is 17. So the person is 1.8. The person's shadow is 0.7. The monument's shadow is 65.8. And we want to know how tall is the monument. So let's do little to big. So I'm going to put 1.8 on top and 0.7 because they're both little. What corresponds to 1.8? No, in the big. M in the big for 0.7. 65.8. So now you're going to do 0.8. 7m is equal to 1.8 times 65.8. And you have to finish that because it's decimals. I don't like decimals. Next. Miriam? Number 19. Can you conclude if the triangles are similar? What's very special on number 19 are those arrows. What do those arrows mean? That you've got parallel lines. Do you see your two triangles? What letters are formed by these parallel lines that could be congruent? Parallel, parallel, transversal. What letter is that? Okay, parallel, parallel, transversal. So you know that this angle in the big triangle is congruent to this angle in the little triangle. This angle over here in the big one is congruent to that one in the little one. So by angle similarity, those two triangles are similar. It says state the postulator theorem and write a similarity statement. This is your similarity statement. Triangle TSM is similar, 19, is similar to NLM. That's what they mean by similarity statement. One more? Stephanie? 15. At least on this one, they drew you a picture. This indirect measurement is going to be, I guarantee it's on the EOC. It's been on the FCAT. It's been on the HSCT. It's been on all Florida's tests for years. It was on FCAT. All right, so this is a right angle. What do we know about these two angles? So by angle, similarity, they are similar. They told us this was 135. They told us this was 90. They told us this was 120, and they told us this was x. Why does this have to be angle? Why couldn't it be side, angle, side? Well, there's two sides, but do we know that side? So we can't see if those are in proportion. So if I do small, 90 is small, 120 is small. What corresponds to 90? What corresponds to x? I should say 120. So you've got 90x is equal to 135 times 120. X is equal to, I'm going to do some number magic. 3 goes into 135 45 times, 10 times 12. 90 is 9 times 10. The 10s are gone. 3 divides 9 3 times. 3 divides 12 4 times. There's my number magic, 180. I didn't have to touch a calculator. Yes, or I could, but people would have wanted to know how we got that. Important that you can do that, or else that you can multiply big digits. All right, so I'm going to go ahead and go to the homework or the new lesson, and I'll come back if we have time at the end. All right, we are on section 7.4, and this is similarity in right triangles. This is an altitude. This is an altitude. Altitude starts at a vertex perpendicular to the opposite side. Everybody see that altitude? All right, when an altitude is drawn to the hypotenuse of a right triangle, then that separates my right triangle into 1, 2 triangles. Agreed? But we also have the what triangle? The original large one. You with me? Do you see all 3 triangles up there? So where they're saying that the large triangle in yellow, 7.4, is similar to the medium triangle, which is number 2. They're saying the large triangle is similar to the small triangle, number 1. The medium triangle, 2, is similar to the small triangle, 1, because they're both similar to the large. So I don't know why I have this. I think I should not have written this, and that was my conclusion. 7.4. Every when the altitude of a right triangle is drawn to its hypotenuse, it separates it into 2 similar triangles that are similar to it. Yes?
Why is there like a capital A and then there's lowercase a?
Capital A is the vertex, lowercase a is the side. Okay? But I just want you to know that this similarity relationship exists. And by looking at it this way, all your triangles are oriented differently. You with me? Okay. If you were to try to take these triangles apart, this triangle number 2 would have to be drawn like this. Okay? Where this is D, and this is C, and this is E. Then you can see the similarity between the 2. The little baby triangle would have to be drawn like this. The hypotenuse is A, the small leg is B and E. So unless you're really good at separating these, then this can be visually difficult. But we can take that visual difficulty, whatever. We can take that away through a theorem that we're going to have. Okay.
Are we trying to find that they're similar, or?
No, we know they're similar. All right, so this is the statement. Are you ready? When the altitude I spelled that wrong. I've been challenged today on my spelling. Altitude. When the altitude is drawn to the hypotenuse of a right triangle. Bless you.
Thank you. Wait, are we getting all right triangles?
They're all going to be right triangles. Then and I'm going to have to go back a minute, but let's go ahead and get this written. Then the altitude is the geometric mean. No, I just know it. Is the geometric mean between the segments of the hypotenuse. It's amazing. I could read or recite any of these theorems in the book. And then the large, no, let me rewrite that. Leg of the large right triangle would be better. And the legs of the large right triangle is the, I should say are the, yeah, let me do that, are the geometric means, between the whole hypotenuse and the segment of the, keep writing, don't give up, hypotenuse, and the segment of the hypotenuse next to the leg, closest to the leg. What do you want, next to the leg or closest to the leg? Next to the leg. I guess that's less writing. Good call. Little sidebar. We're going to go back, and we're going to talk about a geometric mean real quick. Do you remember when I had the ratio A to B equals C to D? Do you remember that? And we called these inside ones the means? Yes? And the outside ones were called the what? Extremes. Now, when we set this up in fraction form, where were the means? B, C. That's the mean position. So when that theorem talks about the geometric mean, the altitude occupies these two places, the large leg occupies these two places. Are you with me? So we really did do this. I just needed to bring this back to the forefront of your minds. Because they are the means. And when we come over here and we say the altitude is the geometric mean, that means that the altitude is going to go into this position of our proportion. Tonight, all you're going to be doing is proportion after proportion after proportion. All right? And, I mean, after 20 years of teaching this, I have boiled this down to be as simple as possible. Now, this does not look very simple, does it? Okay, so this is what we're going to do, is I'm going to take these two statements and I'm going to put them in a proportion format that's going to look a whole lot easier. All right? So we're going to start with number one, this is number one, the altitude. The altitude goes in the mean position because it is the geometric mean. Are you with me? Okay. Then, what did it say it was the altitude? Between, the mean between. Segment, and it's going to make sense in a minute, of hypotenuse. And then this is going to be other segment of hypotenuse. So let me draw a picture so you understand what I mean by the segments of the hypotenuse.
Yeah, right there, the top one block.
Right. This altitude separated my triangle, my hypotenuse, into two pieces. Do you see those pieces? That's what we're talking about. Other segment of hypotenuse, segment of hypotenuse. You with me? It's even color-coded. Tell you what I'll do. I'll even do this. That is the altitude. The altitude is the geometric mean between the segments of the hypotenuse. It doesn't get any better than that. Okay? Color-coded for you. If you got highlighters, get it. Do it. Okay. Number two. Yes.
I'm actually really serious when I ask this. Like, when are we going to use this? Because I was just thinking to myself about this. Like, there's not a lot of examples of like real life scenarios. Like, unless you have nothing to do, you want to take over.
No, I don't have time. Later. All right. The second part of this. The second part of this has to do with large leg, all right? The large legs. Large leg. No, I'm going to say leg of large triangle. I think that will help you. Leg of large triangle. Okay, the leg of the large triangle is the geometric mean, so it goes into this position. Okay? Now, what is it the geometric mean between the whole hypotenuse and then the segment of hypotenuse next to the leg? Okay? Now, there are two large legs, so that means that produces two proportions. Mm-hmm. So I'm going to...
Wait, so do we put 1 and 2 together?
Do you remember the 1, 2 up here in this big, long, wordy stuff? 1, that's what I'm referring to. Okay, so the leg of the large right triangle. Do you see the leg I just drew? Okay. It's the geometric mean between the whole hypotenuse, the whole entire length. Now, which segment is next to it? Do you see that? That segment of the hypotenuse is closest to the green. That's what we're talking about. Now, could we have used this leg? Oops. Could we have used that leg right here? Yes? That hypotenuse is still the same, but do we pick a different segment? Yes, we picked this segment. So I want to do, I'll probably post 2 sets of notes up. First period where the microphone had to pick me up from the computer, and then this one. So I think I'm going to work towards the back of the notes forward to do problems I didn't get to first period. So when you go to do these problems, this is the way you make it easy. The first thing you do is identify all means. Identify all means. And then you're going to set the means in the mean position of proportions. Where B and C were. And then after that, you're going to fill in the rest of the proportion, fill in remainder of proportions. And then it's just solving proportions. You're going to solve more proportions today than you have in any of these lessons. Hold on. I'm not finished. It's all going to come together in about 60 seconds. So we identify all means. We set the means in the mean position. We fill in the remainder of the proportions. And that's step 3. Identifying the means is part of all that writing above. Filling in the remainder of the proportion is part of all that writing above.
Wait, is it like, you use 1 for 1 problem?
It's going to be 3, up to 3 problems.
In 1 problem?
Yes.
How many problems?
I don't know.
No, I mean,
Not very many book problems. I know that.
so you use both proportions in both 1 problem?
Do you use both proportions? One, okay, you ready? Let's do one.
9, 18 through 22, 31, 10.
Let's do this one. You ready?
Is this a lot of work, like, to do? I need to know.
Yes, it's a lot of work. Okay, here we go. So the first thing you're going to do is you're going to identify the means. Identify means. 10 is a mean because it is an altitude. What's another mean?
What is mean?
It was just,
What's another one?
is it just, yeah, I thought it was just,
No. No, 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 no. Here we go. Altitude is the geometric mean. What's the other one? Legs of the large right triangle are the geometric means.
So it would be
So what are the legs of the large right triangle? 6 is not a leg of the large right triangle. Look at the big triangle. X is one large leg. What's the other? Nope.
W plus 6.
So when you're setting up the means, you've got to look at this triangle as a whole. Do you see that big triangle? That's the hypotenuse, that's a leg, that's a leg. We're talking about the whole big thing. You with me? Okay, now, 20 is the hypotenuse of the medium. Ignore that line in the middle for the legs, okay? So now what we're going to do is we're going to set up 3 proportions. So here we go. We've got this proportion, we've got this proportion, and we've got this proportion. What does means mean? That means 10 goes in the mean position. X goes in the mean position. 20 goes in the mean position. That's what that means. Now, this is the altitude. So now the altitude, if you look at your proportion, it's this altitude is a geometric mean between what? Segments of the hypotenuse. This is the big hypotenuse. It was separated into what?
Oh, the segment, and then the
What's one segment?
other segment.
6 is one. What's the other one?
10.
W. 10 is the altitude. This is the hypotenuse. That altitude cut it into 2 pieces. What is this whole hypotenuse? W plus 6. So when I go to do these legs, we do the whole hypotenuse. Now I'm working with X. Which segment is closest to X? 6. So we're going to do the whole hypotenuse. Which segment's closest to 20? W. So the extremes are involved with these numbers on the hypotenuse. I can't solve either one of these. Oh, I could do this one. So let's start here. We've got 6W equals what? Or W is equal to 100 divided by 6, or 50 over 3. Shouldn't I have an X somewhere? All right, do I already have W? So I don't need this proportion. I do. W is 50/3. Right? So now I've got 50 over 3 plus 6. Where did I get that? Okay. So we're going to have x squared is equal to 6 times 50 over 3 plus 6. Can I distribute? Because look what happens when I distribute. That's going to be 300 divided by 3, right? Plus 36. So x squared equals 136. Now what do we do? 6 times 6 is 36. 300 divided by 3 is 100. And I added them. Okay. So we square root, we get 2 answers. Now, I'm going to ask you to simplify this. 136. What multiplies to give you 136? 2 times what? 68. What multiplies to give you 68? 2 times 34. What multiplies to give you 34? 2 times 2 is 34 is 2 times 17. When you simplify a radical, square root saying what was multiplied by itself twice. What was multiplied by itself? 2. So there are not 2 2's, there are not 2 17's, so that stays square root of 34. You need to be able to simplify radicals. I wrote 35. How did I do that? What was multiplied by itself, Brian? Do you see it? What was multiplied by itself? 2. That's what the square root asks. What was multiplied by itself? 2. What was multiplied by itself? Nothing. There aren't 2 2s and there aren't 2 17s. All right, so now I'm going to go back to this one. I need to do another one. You can get it tonight. So what are the means on this one? X is the altitude. Look at the big triangle. Z is a large leg. Large leg, and Y is the other large leg. So what do we do with those? We put them in the what position? The mean position. Because is it not a leg of the large right triangle? So X is the altitude. What is it the geometric mean between? 8 and 5. Now, Z requires the whole thing. What is the whole thing?
8 and 5.
Which is 13. So whole hypotenuse, this is Z, and which segment? 8 because it's closest to Z. Y is whole hypotenuse. Here's Y. What is it going to be? 5. That's it, guys. That's all you have to do tonight. So you got X. Now watch. That's it. That's it. Yeah, no. Piece of cake. All right. Shh. Listen. I have to square root both sides. I get plus or minus. There is no reason to make that 40 because you're just going to have to say what times what is 40. So what times what is 8?
2 times 4.
2 times 4, and 5 doesn't divide anymore. What's the square root of 4?
2.
So that's going to simplify to 2 square root of 10.
Oh yeah, this was last year. I don't get the why they're separating and when to stop.
Z squared equals 13 times 8. Hold on, I'm going to answer your question. I have to square root both sides. If I multiply 13 times 8, then I'm going to have to say, okay, well now what multiplies to give me that huge number? Why bother? Why don't we start here? What is the square root of 4? 2. And 13 doesn't simplify 26, or 2 doesn't simplify, so Z is 2 square roots of 26. This is going to be y squared equals 13 times 5. Y is going to equal plus or minus. Does 13 simplify or does 5 factor?
No.
Nope. So the best you can do is to multiply those together and get square root of 65. Uh-huh. It's all about being able to first identify these means, and second, knowing how to fill in those other positions when you are finished. Pardon? Down? Yes. That's 13 times 5. 13. Say it again.
The X, the Y right next to it.
That says large leg.
Oh, okay.
Those are little, ditto marks.
Oh, okay.
So I didn't have to write it again. Homework! Back table. When I don't collect it in class, you put it on the back table. Homework, back table.
Wait, so you only separate the numbers before you forget it?
Right. And then you ask yourself, pick out the pairs. What was multiplied by itself? Each pair comes out whole. Not 2 times 2 doesn't come out as 4. The question is what was multiplied by itself? 2. So a 2 comes out. And those 2's then are gone. If you have 3 times 3 times 5, what was multiplied by itself? 3. And 5's left under. 3 square root of 5. 823 is part textbook, part worksheet. But